Okay, so today we'll solve GET 2022 question. This is a question from functional analysis. It is a question number 16. So it is saying that let EK be an orthonormal basis for the Hilbert space H and define FK via this EK plus EK plus 1 and Gj is summation n equals to 1 to j minus 1 to the power n plus 1 En. Then you have to compute this series summation k equals to 1 to infinity mod gj inner product fk no square mod square. So 4 options are given, you have to check which one is correct. Okay, so in order to solve this is the NPTEL reference. This you can check for the references. Okay, so let's try to solve this one. So we have to find this series. Okay, so what is given? Fk and Gj. Ek for k belongs to n is an orthonormal basis for H. Right, and Fk, what is Fk? Fk is defined to be Ek plus Ek plus 1 for k belongs to natural number. And how Gj is defined? Sum n equals to 1 to j minus 1 to the power n plus 1 En, right? So Fk and Gj are defined. I have to find the inner product Gj with Fk first, then we have to find the sum. So what will be this? We have to find Gj inner product Fk. So let's find this one. So what is this? Gj is basically this sum n equals to 1 to j minus 1 to the power n plus 1 En, and Fk is Ek plus Ek plus 1, right? So note that Ek's are orthonormal basis. So for k not equals to some k dash, they are 0, and if this becomes same, then their inner product will be 1. So use this one, right? So what we will get? So suppose j less than k, strictly less than k, then in this sum all the term is less than k, right? So if you take the inner product with this one, you will get 0 because this is k and k plus 1. So for this you will get 0 if j is strictly less than k. Now what happens if j is k? So this case, if j is k, so there is a then one sum Ek will be there, and this is inner product. If you take Ek, so you will this inner product will be 1, and so you will get this sum, right? So for j equals to k, you will get this only one term minus 1 to the power k plus 1. So when j equals to k, only that inner product will be non-zero, otherwise all the inner product will be 0. And what happens if j is bigger than k plus 1? If j is bigger than k plus 1, so suppose, so there are, so because here it is only 2 terms, so only 2 terms here will matter, k and k plus 1. All the other inner product will be 0. So k and k plus will be there, certainly, because j is bigger than k plus 1. So therefore whenever Ek and Ek will be there, it will get 1. So you will get this coefficient minus 1 to the power k plus 1. And whenever Ek and Ek plus 1 will take the inner product, you will get minus 1 to the power k plus 2. Right, so these 3 possibilities are there. And now look at this, whatever, suppose this k is even or odd. So if this is even, then this will be odd, and if this is odd, then this will be even. So one thing will be plus and one thing will be negative. So what you will got basically? So this is 0 for j strictly less than k. This is minus 1 to the power k plus 1 if j equals to k, and this is again 0 if j bigger than k. Right, because one thing will be even, one thing will be odd, so one will be plus 1, one will be minus 1. So this you will get the inner product. Now we have to find this, right, this series. So what will be this series? So then summation k equals to 1 to infinity, right? K equals to 1 to infinity gjfk. gjfk. So if k is bigger than j, then so let's break it into 3. So sum so first sum when k is j minus, right, so this is so k equals to first 1 to j minus 1, this sum first gjfk plus the next when, so this is only the jth term will be there, so it is gj comma fj, right, and the last when k is bigger than j, so k equals to j plus 1 to infinity. So note that this term will, this is same as k is less than j minus 1 plus what is this term? So gjfk when k equals to j, basically this is, so let me write it first. Plus this sum is basically k is bigger than j, right? Now what is this? So first one for j k less than j minus 1, this is 0, so the first term is 0. Second term corresponding to the k equals to j case, so this is minus 1 to the power k plus 1, so this is minus 1 to the power, here will be j plus 1 square plus this term again for the k bigger than this case, so this is again 0, so this will get 0. So what will be the sum then? So this is minus 1 to the power, so it will be plus 1, so the sum will be 1. So this series sum will be 1. So what you have got? So which option is correct then? So 0, which is not true, j square, this is also not true, this, so the sum will be 1. So option D is the correct one. Okay, so